Alright, time for another draftphysics.com, debatephysics.com also. But, yeah, debate's hard to come by. And some of the talking head, whatever, YouTube science pontificators, talkers, yeah, they just don't know the concept of debate or argument is something they consider to be hostile or some sort of offense to the scientific process rather than part of it. That good science is testing, and you test things through arguments and counter arguments. Einstein did a lot of that. You have to defend your positions. And so, there's a video titled Long Live Scientific Debate. I don't know whether that's satire. And yet she's right here in the description says, I won't debate you, here's why. And it's some ragged pile of crap about, one of these snowflake people who won't debate and they'll decide what subjects. And that's fine. You can say, look, I don't debate some subjects because I consider it a waste of time because you have no argument. Okay, so you just say, I won't argue non-argument. So if you can't present evidence and reasoning and logic, well, I'm not going to debate you then, okay? If your reasoning is your faith or, the fact that you think you were abducted by aliens or some other kind of unsubstantiated shit, well, then, yeah, you have no obligation. But that's not what this is about, okay? This is about debating what you're saying, okay, on the internet, and that people do have a right to challenge that crap, and the fact that you're too afraid to counter those arguments just makes you a cheater. So, and you're doing it as a woman. So again, you're only playing into the cliche, okay? You can't take the heat of the scientific kitchen or the philosopher kitchen, or the talker's kitchen. So what? You belong in a real kitchen because you can't do real physics, because real physics, the requirement is that you have to pass tests, and you have to, have the goods, and, you're too afraid of that challenge. You're afraid to take the test. It's just so, oh, I can't take the test. So yeah, you don't, you're saying what? You're getting cheated because you're afraid to take a test and have your ideas challenged. I mean, it's just so disgusting. All right, but anyway, so this whole video is a pile of crap, as they all are. She doesn't get around to anything. It takes 15 minutes to get to it. So she says that John Dalton defined atomic theory first, 1800-ish. Okay. And, clearly, this is just bullshit. So, I'll play this bullshit, but it's just bullshit. Okay. I mean, obviously a ton of people already knew there was atoms. I mean, Faraday, Faraday's, a little later. He's earlier than Dalton, but you go back to like Newton, okay? He was doing all that alchemy. Clearly, they had already separated elements. So, they already knew what, iron was, and they already knew, whatever, 30 or something like that of the elements in the periodic table. So they already knew that there was this little bits of stuff that you could collect out of the environment and collect a whole bunch of the little bits of stuff that were called gold. So atomic theory was already a thing. And, the fact that this guy articulated some clear statements about what the properties of these atoms must be is not miraculous. And it's bullshit to say he invented it. Okay. So it's just sort of a nonsense pile of crap to premise this argument that later on in the 1800s, Mach and some other people said, well, we never seen one of these atoms. And it's true, that we don't see them except secondhand. And so, we can't go too far in deciding what they are. And then I would argue that they caught on an idea of the solar system spinning electron model that was crap. And it really isn't. It hasn't been proven as a theory. The whole idea of shared electrons that are moving whatever half the speed of light is, in my opinion, almost on its face silly. you know, but whatever. Okay, so let's play along.
Give him some slack. Come on, don't be rude. Number 4 is that atoms of different elements can combine to make chemical compounds with only specific ratios.
All right, so now that's that's more than I think Newton could have recognized. But clearly they knew oxides and they knew lots of stuff. So they knew that certain kind of combinations were a lot more likely than other kinds of combinations. They knew about acids and bases. So again, it's really atomic theory was well in the works long before the 1800s.
So you cannot make water with 2 hydrogens and 2 oxygens. That's not how that works. And the final thing is that he described chemical reactions as a way to move around molecules. So you can break apart molecules, you can combine them together. The individual.
So again, Newton sat there for years with furnaces and things doing all of this alchemy stuff, okay, trying to make elements into another element and extracting elements. So, I mean, it's clear that they understood that there was some substances in the universe, some fundamental substances, and you could pull the substances out of you could take a rock and break it, and you could pull the substances out of it.
Atoms do not change, but the chemical reaction is the thing that will move them around. And that's like a lot.
So the chemical reaction moves them around. Well, maybe the moving around is what causes the chemical reaction. So again, this is all gets to be how you describe words. So later she's going to start talking about other disagreements about the nature of how the universe should be viewed or how physics should be understood. Now, I'm going to argue in defense of the simple logic, the foundation built by Galileo, Newton, and Descartes. And not everything they said was right, but a lot of it was. And, the simple truth that this energy stuff just keeps moving. There's no such thing as using energy, okay? In the sense that all you can do is transfer it from one place to another place, and that transfer, that transition, changing something by putting energy from one place to another is an event that can have useful purposes to us. But the energy itself is doing something rather mundane. It's just going from banging into little things, a big thing banging into little things, like a boat sailing, and though it hits the wind, it hits the atmosphere, and then the sounds, travel, so you're taking vibration energy and you're taking it away by allowing it to communicate and bang into other atoms and make them move. So you just take it from something big and make it small, or you take it from something small, like electricity, and you turn it into something big, like heat, or something big that causes something big to move. Like an engine on a boat, or a propeller spins, whatever. But you take motions in small, discrete chunks and turn it into some sort of big thing moving. And that's all the universe is doing. Little stuff moving turns into big stuff moving turns into little stuff moving. That philosophy, okay, or that overview perception of the reality, I would argue is good science. It's well defendable. I mean, I could play the Professor Lewin clip again, about momentum. Nature can deal with kinetic energy one way or the other. That is, it can make it disappear and it can make free kinetic energy, but nature can't finagle momentum. But they don't believe that. So she totally evades this whole living force controversy, which is one of the biggest debates in science that's just been ignored. But it went on for 100 frickin' years, and it wasn't resolved. Okay, nobody showed up with the big ball of proof and said, look, here's the big ball of proof, now it's over. Okay, here's your genetic evidence, here's your fingerprints, here's some kind of real evidence. That's not what ended it. It ended in this disgracefully, this whimpery compromise of wave particle, of Oh, well, we just have two kinds of energy. We'll have this thing called momentum, and then we'll have this special fun stuff called kinetic energy. And it's all just bullshit stories. And they all should be attacked and they should be tested because they're premised on garbage, no fact. Okay, again, Leibniz defended kinetic energy with the mere bold statement that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. And it's not the same. It's not the same energy. It's not the same impact force. It's not the same momentum. You just declared it to be the truth.
That I don't know if you know much about atomic theory, but for 1800, that is a huge amount of knowledge about atoms. Because if I switch and I put in my physics brain, and you say,
No, so she's talking about having two brains and blah, 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 blah. Neither one of them wants to argue. No, neither one wants to defend their position, what they're saying the truth is. All right.
who's responsible for atomic theory, I would be like, so in physics you
Right. So the fact is, it was incrementally deduced the existence of atoms, and eventually it was proven. But I mean, a lot of people believed in them before they were found. At least they believed in this molecular idea because they clearly could do it. Again, they could break a rock and they could, heat it up and they could extract elements out of it. So, they could put electricity. Well, this is later. Through water, and they could end up with hydrogen and oxygen, two different gases. So they clearly knew there was elemental stuff that had to be, you'd sort of kind of deduce that it must be in little clumps all over the place, and that you're just collecting all the clumps that are that type. So the clump theory, okay, existed in a lot of scientific minds. Let's just say that. Okay, the idea that the world is made out of clumps of materials that have an affinity for each other was not that are the same element. That you could get a little bit of gold out of this rock, you get a little bit of gold out of that rock, you could get a little bit of gold out of that rock.
have Bernoulli, one of the Bernoullis, in like 1740, he talked about pressure. Pressure is...
Yeah, so pressure, you could say, well, let's talk about weight. So if we said that pressure is just weight, okay, in a unit of time, so you're applying a weight. And what is a weight? Well, a weight is a momentum. You can make weight by having momentum. So the earth, the gravity pushes you into the earth pressure of the earth, the weight of it always having to push, always being at equilibrium with the forces pushing in, is already pressurized. So you're pushing into a pressurized substance. The pressurized substance pushes back with a little bit more pressure because you've increased the pressure by imposing on it. By imposing on it, you've increased the pressure, and therefore it pushes back. And but you had a momentum. Okay, your gravity pushes you into the earth with a momentum. You push into a scale. The scale registers the pressure differential because you do the first act. That's what the scale is reading, is the first act. All the rest of the acts cancel. And so you see the first act, which is you putting pressure. And the fact is, I just turn that scale and now it's a momentum. The same force, okay, that gave you weight now is giving you momentum. It's the same damn thing. So an energy theory saying is the core of physics is about just the migration of movement in the universe. It's just about the stuff moving. And it can move as a force, moving the speed of light in electromagnetic radiation, or it can move as electrons and protons, material bits, or whole atoms in motion. And they're being moved because they have force pushing them. So it's that theory works just fine. And it's only because you have a little traditional notion of stepping on cracks, you have your own little superstitions, that you're just pretending and telling us stories about the kinetic hobgoblins. There are no kinetic hobgoblins.
Is caused by the motion of atoms. And then Maxwell, the famous Maxwell of electricity and magnetism.
Right, so again, famous mathematician, okay, who just consolidated other people's, the relationships that had already been discovered and certainly were known in vague terms. And, obviously a lot of people, Ampere and Ohm and all these people, took that information and turned it into more explicit and detailed, more rigorous mathematics, let's say. And all Maxwell did was put those things together and recognize the implications of the fact that there's the radiation part of the event. There's an event, and then there's a subsequent radiation that's the consequence of that event. But it's still just the idea that you're just changing how energy's moving objects. And I suppose the key point missing is, in terms of Maxwell's understanding, is recognizing the difference between the existence of energy that's benign, that is, you hit something and you make it wobble but it doesn't tip, and the idea that you hit it at the right frequency and you knock it over. Those two events are fundamentally different. Same energy, just a different outcome.
He also had a paper on molecules from the 1870s, so this is, 70 years after John Dalton, where Maxwell says this: "We are told that an atom is a material point invested and surrounded by potential forces, and that when flying molecules strike against a solid body in constant succession, it causes what is called pressure of air and other gases."
Yeah, and so he's sort of getting to the point that there's the ether. He was an etherist. So let's understand that in that context, that he would imagine that the ether would be moved or perturbated by any matter moving. And you could argue that what's missing from his understanding is the ether isn't a dead ether. It isn't jello waiting for you to poke a hole in it. It's actually an active, heated force. That is, it's already got movement in it. It's already moving. All of it's all moving. Dead stuff can't do anything. The only thing that can do something is something that's moving, and the force has already got energy in it. And so that's the flaw in his visualization. And so again, you could argue all of this could be argued, and each one of these physicists had a uniquely different, subtly different vision of the function of the mechanics. And I'd argue that it was starting to get really confused in the late 1800s, just because of wave particle. You have two kinds of energy, and I have momentum, and you have this kinetic energy theory stuff. Okay, and it's just all kinds of noise is all it is. It's a lot of noise, not too much signal.
And then Boltzmann in 1871 describes the Maxwell-Boltzmann distribution. He introduces the idea of statistics and entropy.
So again, the idea of what this stuff does in mass, being able to just follow the fact that we can't see the individual particles, but we can see is what a million of them will produce as an outcome. 10%, 20% of this, 5% chance of that. You can shoot a bunch of radiation into something and say only 1 in 1,000 events actually hits a nucleus, that kind of crap. So you can do this statistical stuff, and that's all valuable evidence, and that's all it is. It's just physical evidence linking, a cause with an effect. But they take that too seriously, because it is made out of individual objects, and it isn't a probability theory. So now, the consequence of Boltzmann is taking it all the way to the extreme of a Feynman, who sits there and says, no matter where the photon goes through the slit, it's randomized. So somehow it's affected, even though there's no likelihood that it could possibly affect. I mean, one surface is way over here and one surface is way over here, and the photon's this discrete thing here. How the hell does the photon get interfered with by going through two openings, two surfaces? So yeah, they start turning what things do as a group, which you can expect as an outcome, and say everything is just a probability theory. When no, there's real dice that you're rolling, and frankly, there's in the circumstance of the slit experiments, there's real surfaces that are actually causing the effect. And nobody, none of these scientists could figure that part out because they don't need a mechanical theory of physics. They turn physics into an abstraction, into some sort of mush that things just happen. There isn't a mechanical cause. It just happens.
Clausius also had entropy, but at an atomic level.
Right, and so entropy doesn't mean anything in a gravitational universe, does it? Can you really argue that entropy means something in a universe run by gravity? I mean, obviously the gravity's clumping things, okay, and it's doing it rather effectively. So it's pretty silly to argue about this idea, this entropic principle that everything reduces to something small moving, when no, there's a big, huge, giant part of the universe that's taking the small energy, the force, and smashing a bunch of matter into unentropic associations.
Boltzmann is saying, here's entropy, and we can describe systems of atoms with statistical rules.
Yeah, probability. Again, so it's just, statistical rules, just another way of saying, okay, that, if I throw a Mexican jumping bean in a box, it's going to hit all the surfaces eventually. All right. And then you can make rules about what happens in a corner, right? Because it can't get to the corner, so it never hits the corner. So you could say there's a higher likelihood it's going to hit a certain piece near the corner more than it's going to hit some other piece of the surface. So you can come up with some sort of relationship that's perfectly understandable once you can connect the dots and understand what the physical mechanism is. But if all you're saying is, all right, there's more hits on this piece of the surface, and I'm not going to tell you there's a corner there, and now we're just going to come up with a magical explanation for why there's more hits there. Well, no, you don't need a magical explanation. You can understand it physically.
Leads to statistical mechanics, which is, of course, a very successful atomic theory.
It was very successful. How? Again, very successful. What? It invented airplanes or something? What did it do? So again, this very successful crap that they keep spewing about, we circularly created a circle of math. Okay, bullshit connects to bullshit, connects to bullshit, connects to bullshit, connects to, whatever. Huygens, hobgoblins. Huygensian hobgoblins.
I just think that's really interesting. I beg.
Yeah, well.
Of you, if you know a chemist, ask them who did atomic theory, and then go ask a physicist, and you will get two totally different answers.
I really don't think you will, but whatever. I mean, I think the chemists know that theirs is a specialty of physics, that it's all physics, and there's nothing else. I mean, the elemental universe, the little tiny bits in, the electrons and protons, their universe is the only universe. And there's no smaller verse. There's just electrons and protons in a field of energy, force. And that's it. Doesn't get any smaller than that. I bet you. Yeah. There's absolutely no indication, okay, that you can find a smaller verse, because every single electron appears to do exactly the same fucking thing when you put it in the same fucking circumstance.
And it's very funny because in the 1800s, chemists were working with atomic theory, like, yep, atoms, we got it.
More specifically, they're working with the whole fucking heat energy transfer thing. Every single chemical reaction either consumes energy or it produces energy. Okay, it either takes energy to make it happen, and it's going to store that energy in the new thing you made. That's where the energy is going to be locked, you extracted. The higher pressure you put in. is going to stay in the new molecule you made. And the other case is you break something and a bunch of little extra free bits fly off.
It's fine. And in the 1800s, up until the late 1800s, physicists were arguing about whether or not...
Why were they arguing? I mean, it's all not debatable, right? These are all our personal opinions, and they're sacred, and no one should have to be tested, and should have their silly notions scrutinized, and there certainly shouldn't be any obligation for somebody to defend the silly shit they say. Yeah, fuck that.
Atoms exist. I thought the physicists were supposed to be the smart ones. That was a joke. I know.
Oh yeah, whatever. Whatever, this dry wit.
Chemists are smart. It was a joke. It's fine. So today, the plot of this video is the topic of scientific...
All right, so it's really not, because you're just evading all the big subjects and just dealing with the fact that, frankly, Mach was an idiot. Okay, so he had a lot of wacky notions. Einstein liked them, and then Einstein didn't have any use for them. But I mean, yeah, he said a lot of crap that was just stupid. I mean, the whole Newton's bucket theory, his big solution was, well, how do you know the universe isn't creating super gravity when it spins? When the whole universe spins, somehow it's going to make more bucket gravity stuff. Well, could, maybe. Yeah, really dumb.
Debate.
Like spinning the universe would somehow make more gravity, right? That's what the argument is. You have a bucket, and you're saying, okay, when the bucket's spinning, I can make the water move. But, okay, if I spin the whole universe, the water isn't going anywhere.
And I want to talk about a very specific debate that was in the thermodynamics community, because apparently my personality is just talking about thermodynamics.
Yeah, whatever. And it's like a really important subject. I mean, and it goes right to the core of the kinetic energy theory, because it just breaks all thermodynamics. All of a sudden, little things moving fast somehow have more energy than big things moving slow. That somehow one atom going 1,000 miles an hour just has this capacity to give more energy. 1,000 times more energy, all right? So that's what they're saying, right? So if I have one atom and it moves 1,000 miles an hour, I have 1,000 atoms that are using 1 mile an hour. This one has 1,000 times more capacity to somehow exchange its energy. That is, take the force that it contains and spread it to other objects. It somehow has 1,000 times more stuff to spread. If it was peanut butter, that somehow it has more peanut butter because it's a small one thing going 1,000 miles an hour. And the logic of that is stupid. So we're back to pressure and weight and momentum again. They have the same momentum. They have the same capacity to move shit in the universe. Things with the same momentum have the same capacity to convert their motion into smaller things moving, or their motion into a bigger thing moving.
I'm fun, I swear.
Whatever. So why is she playing with these words? Long live scientific debate, when she's hostile to the word debate. Again, right in her description. I won't debate you. Here's why. Because my views are sacred. It's the sacred woman knowledge. Or something. I don't know. What the fuck is that shit? I won't defend my position. I just preach. Okay? That's my job, is to distort and pervert little minds. Okay? Small minds. The uneducated. The people who don't think you have to earn it. All right? You just show up and, everybody's supposed to say, sure, I believe that. Because you said so.
Try Old Spice Total Body with 24
fuck that.
7 freshness from pits to toes.
I don't even know who these commercials appeal
This
to.
is our world.
Who the fuck buys
Throughout
something because of this
generations,
shit? God damn it.
Let's set the stage. It's like the 1860s.
What the fuck is this shit? So all these little petty, silly jokes. Ugh.
They're really into like Kantian philosophy, and you have this camp of natural philosophers who are now calling themselves.
So again, like everybody was a Kantian when no, that's not how it worked either. And Kant didn't even have a philosophy in the end. His philosophy was, oh, I can't rationally defend God, but shit, we really need him. Yeah, he must be here somewhere. All right, that's not reasonable to believe, but who the fuck says we have to be reasonable? Yeah, that was brilliant shit.
Physicists who say we should start thinking more about philosophy.
There's an overview, okay, about the specific conceptual view of the universe. So you could say it doesn't need any math to understand the idea that there's elemental chunks to something, and that you're just saying, well, if the chunks are dispersed, okay, one thing, the universe looks one way, and if the chunks are, in all been segregated. So look, you could analogize it. I started this channel with an analogy of a school of fish. Because a school of fish can have a ton of motion in it, and it's not going anywhere. Or the school of fish can have a ton of motion in it, and it's all going in one direction, because all the fish have agreed. All right, and it's a very different thing. The same exact amount. Each fish is still only swimming 30 miles an hour. Let's just say number. And it can do 30 miles an hour. The fish are all doing this work, but they're just in one place. Or they can do the same work and be getting somewhere. So that's the conceptual reality that math really isn't going to. You're not going to be able to illustrate that with a mathematical formula. You're not going to be able to reduce that to a sentence of math that will mean anything in terms of a concept.
Look at all of these physicists, like Ludwig Boltzmann. Here they are saying that they're doing statistics with atoms and no one's ever seen an atom. How can we do physics with things that we cannot see? How can you say you're measuring something that you've never seen?
Well, that's not really the point, right? Because you go back to like Stern-Gerlach, right? I mean, the argument isn't the value of experiment and the fact that it's good to find out what these probabilities are. The point is that you shoot silver atoms and then you start talking about electron spin. You're not shooting electrons. They're not electrons. How the fuck are you deducing electron spin from big giant whole atoms, ions traveling? How the hell does the direction of the ion tell you what the electron is? I mean, that's a huge stretch. I mean, you did it all the fucking time. And every single subject, you say, every time there's an on-off pattern, us physicists know it has to be interference. Oh, yes, it is the simplest pattern in the universe, on, off, on, off, on, off. Yes, it is the simplest possible pattern. But every single time it happens, it must be the magical interference. I mean, that's the bullshit.
Ernst Mach very famously says, I do not believe in atoms. And people start agreeing with Mach. He's a very persuasive speaker, and he's held to very high esteem. He's a very successful physicist, of course, but he also did a lot of philosophy stuff.
So we know there's a context to that, right? So we know that he can't be saying, I don't believe in the periodic table. I don't know I think they had the periodic table by then. I don't believe that there's elemental substances. That wouldn't work. What he might be saying is I don't believe in the concept of the atom as, some sort of rigid thing. It's just the addition that anything can be converted into something that'll stick to another element and it'll be the same as that element. I suppose you could be thinking something like that. Like, say if it's all by temperature, all the things of the same temperature would cling together, and you could be separated out, let's just say. So, but whatever, I'm not going to defend Mach. But obviously he must have had some counter theory that you're not including.
And one of the things that springs from Mach's declaration of I do not believe in atoms is this idea of energetics. The main proponent of this energetics idea is a guy named Wilhelm Ostwald, and he...
So nobody's heard of. They remember that hat. But the idea of just calling physics energetics would probably make sense, because it's all just about motion transferring from object to object. That's all that happens in the entire universe, is things are affected by something moving. It hits them, it gives them some portion of its movement, they exchange their motion, let's call it, their state of relative position in the universe. Their future position in the universe is altered by interaction with each other, however you want to describe it. But all of this, there's no universe without motion. It's the key concept, is motion. And you people just don't get it.
Writes up a paper saying that, okay, we can't touch atoms. We don't know what atoms are. Let's throw them away. We don't know anything about atoms. What we do know is energy. That's what energetics is. It's trying to make a complete theory of physics, only talking about energy, how it's transferred among different types of energy, and how you can make a dynamics theory from that. And you can make...
Yes, and it all works, frankly. That's just the whole point, is that you don't... All you really have to understand, again, I could state that there are no such things as atoms, in the sense that that's an abstraction, because the things that are really in the universe are the electrons and the protons. The electrons and protons, you don't really call the solar system, okay? You call it a system. You wouldn't call solar systems atoms in the universe, right? No, I mean, maybe some people would. But the point is they're not elemental. The elemental is the electron and the proton. The atom isn't. And so that's a fair argument to make, that the only thing happening is the only true matter is electrons and protons. They have the phenomenon of charge that's created by their interaction with this field of energy that exists in the universe. So the field of energy produces gravity. It produces the electromagnetic spectrum, light. And what else? Magnetism. But these are all the same thing. They're all moving the same speed. It's all made out of the same stuff, and you're really just talking about patterns in that stuff. So just like the difference between a light bulb and a laser beam. Same stuff, just a different form, a shape. And the same thing happens with the radiation, because you just change its frequency, you change what it does.
Not an atomic theory, but you can explain how gases behave by talking about the energy of that system. And so him and his energetics group write up some papers, and they submit them to a conference that's being held in Germany in 1865. And that's where scientific debate happens. You write papers, you go to conferences, you talk to other physicists. But what Ostwald and the other energeticists don't know is that Boltzmann is aware of them, and he thinks energetics is not a very good idea.
Right, so you could just go back to Bohr and Einstein, and frankly, Einstein didn't think entanglement was a good idea, and they mocked it, okay? Schrodinger's cat, they mocked it, okay? Einstein said, what, you think the moon disappears when you're not looking at it? I mean, what are you talking about? It doesn't need to be measured, okay? It's busy being the moon, and it's always the moon, and it doesn't need us to look at it for it to be there. I mean, these arguments have to take place, and it's not like everything doesn't have a, like somebody's completely wrong and this guy's completely right. The argument is that there's value in all of these points of view, and the real argument is gleaning which ones are based on real evidence and which ones are based on, well, we just assume that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. And as long as we have that assumption, everything we can make confirms, because we can always just apply that assumption and say, well, that fits the rule we established that isn't true. Just as you establish a rule that, Huygens was right about something. When, it can be clearly deduced by looking at the real evidence that the entire slit phenomenon is just about the distance between two obstructions, two objects that create broken photons. And you just put the pieces back together. In phase, out of phase, in phase, out of phase. Not complicated.
He thinks it's pretty bad. He thinks it's not very rigorous. It doesn't explain anything about how gases behave. He's already explained how gases behave. Boltzmann knows, it's statistics. It's atoms.
So again, it's not statistics. It's an image. These people all had images in their head about how the universe worked. Okay, I don't know what Maxwell thought exactly of the ether and all that kind of stuff, whether they think it's elastic ether or whether it's a rigid kinetic ether. Who knows? But they all had a vision of how the universe functions, okay? And now you're really just talking about, instead of talking about physics, which is a vision of how the universe functions, you're just talking about mathematical analysis, which doesn't say anything about that. So I'm saying you're going to get a pretty bad image if all you're using is statistics, because then it's hobgoblins and gremlins and any other crap you make up, because you're not understanding that, well, why does the pressure stay in the vessel? And, well, yes, it's kind of obvious that, you could just deduce that two fast things hit each other, okay? Or let's say two things hit each other and they share their velocity. Well, that means that now the slow one is going faster and the fast one's going a little slower, but still going faster than the rest. And that you can understand how you're always going to have places that are going to be very hot and places that are going to be a lot less hot, because the fact is there's always going to be slow things hitting slower things, and there's always going to be fast things hitting faster things. Averages are going to migrate.
Moving around. So Boltzmann sees these papers that have been submitted by Ostwald and company, and he has his little team just prepare a response. So Ostwald and co.
So again, this is a process that they thought was constructive back then. Okay, so the same thing goes with Einstein and Bohr, and Einstein's compadres against the other, the defenders. I suppose you can go all the way back to Newton and Leibniz, when Newton and Leibniz don't end up arguing. Instead, it's a surrogate and a surrogate.
Don't know what's happening, and let me read to you what happens. Convened late in September 1895, it provided an occasion for the only full-scale public discussion of the status and claims of the new theory of energy. By general agreement, however, the result was an unmitigated disaster for the energeticists. Given the opportunity to argue their position before an assembled body of professional colleagues, they proved singularly unsuccessful in winning converts.
So again, this is one side's opinion, and so you could just go back to the Einstein-Bohr debate. Bohr's last paper against Einstein is so incomprehensible, no one even knows what the fuck he's saying, and yet he was declared the winner of the debate. So again, it's just all bullshit. Who decides? Who's the judge is the problem here, or who's the jury, and whether they're competent to decide. So bullshit. I'm not saying energetics is right. I don't even know what it is. You're not going to tell me what the fuck it is, actually. You're just going to slander it as some sort of mush that doesn't have any real story to it. Where I would argue it probably does have some kernels of truth in it. It might be defending momentum.
For energetics. George Helm reported favorably on the present state of energetics, praising its past development and future promise, while Wilhelm Ostwald forcefully urged the conquest of scientific materialism and the adoption of energetics worldview. But the discussion following Helm's report and the whole tone of Ostwald's address galvanized such vigorous and united opposition, hitherto confined mostly to...
Oh, materialism, how awful. You mean the energetics were materialist? Ooh, scary.
Unpublished correspondence, that energetics was dealt a severe blow from which it never fully recovered. Got him. This is a really serious response. People come to conferences with bad ideas all the time, and usually the person hosting the conference, the person in charge...
Oh, whatever, says you. You know, wait a minute. This is coming from a person who says, I won't debate you. Here's why. Because I'm a girl and we don't have to. Something like that. I don't see anything more to her argument than that. I have magical beliefs. They're not subject to your interpretation.
Of accepting papers doesn't do a planned attack to just so vigorously deny and shut down a philosophy. And when asked why Boltzmann did this, he has this very funny quote. Boltzmann himself confessed that he was not sure whether Oswald was not merely joking.
I mean, the funny part is, right, is that you know, you just go back to the Schrodinger cat. I mean, they took arguments that are supposed to be so obvious, like, how the fuck could you possibly believe this nonsense? And they turn it into a real thing, like, well, maybe the cat is dead and alive. I mean, so that's the irony, is that, you know, you just reverse the circumstance, and you know, it doesn't matter. You know, the right isn't going to win. Okay, these arguments. Obviously, the nonsense side won the Schrodinger cat argument. The nonsense side won.
Which is so harsh. The theory was so bad. Energetics is so silly. Boltzmann thought he was joking. Why?
Right, and so exactly what Einstein thought. What do you mean? You think the moon disappears because people aren't looking at it? Are you that fucking silly? How fucking silly are you going to get? Is his Einstein's commentary. And you fuckers said, well, Einstein's the silly one because he doesn't believe our woo. You know, he doesn't believe in spooks.
Does an essay like the one by Ostwald, seemingly so harmless, appear so dangerous for science? Because it means a relapse into pleasure with pure formalities, a relapse into so pernicious method of so-called philosophers to construct thought structure from mere words and phrases, a relapse into the
mere words and phrases, like, oh, I think there's an ether or there's not an ether, right? I mean, these are basic points to make. Wave versus particle. Is it particles waving or is it waves particling? Which one sounds more plausible? Okay, push versus pull. You think physics would have had that fucking argument and demonstrated kind of decisively, you know what? It's pretty much impossible without invoking spooky hobgoblin force to come up with some way to make an elemental pull. I mean, elemental pull is just about fucking goddamn idiotic. And so, yeah, it's a push-averse. Now, do you physicists say the word push-averse ever? Okay, ever? Has it come out of anyone else's mouth but mine? It's a fucking push-averse, and you can't even figure that fucking thing out because you have no concept. You have no vision. You have no illustration. You have no model that you could draw. Simulate with facts instead of fables.
Method to let oneself rule by prejudice, not to see mathematics because of a lot of algebra, not the true philosophy because of a lot of nonsense that decorates itself philosophically. So this is the real debate. The real debate in the 1800s on I don't believe in atoms is philosophy.
So again, I just argue this really wasn't about not believing in atoms. It was about not taking too big a leap, okay, based on statistical analysis in terms of stating what the truth is. So again, just like the two slit is saying, oh, it has to be a wave. No particle theory can explain. Well, how do you know no particle? How many particle theories did you actually think of? How many did you test? Because you didn't imagine, Feynman's statement, because he can't think of it, it's not thinkable. Because I'm smart and you're dumb. So if I didn't think of it, it can't be a reality. That's physics.
Philosophy versus physics. Because at this time, people are leaning away from calling themselves natural philosophers and moving into specific science.
Yes, exactly. There's this part that's dependent on evidence, okay? I mean, and then there's parts where you're just talking about logical interpretations of circumstantial conditions. So I could argue that life is a zero-sum game, that we're just torturing things for no profit. Those would be philosophical arguments. because there's no arbiter to sit there and say, yes, that pain isn't worth that pleasure. Okay, there's no court you can go to that has the authority to say, that your fun at Disneyland isn't worth giving a kid cancer for. Okay, now I can say logically, I can't see how it's possible for my own testing, sensing, tasting of life that I would sit there and give a kid cancer to go to Disneyland. Okay, I wouldn't do it. Maybe you would, but I wouldn't do it. I mean, how many people would you kill to build Disneyland, right? I wouldn't kill anybody for a fucking theme park.
Scientific fields. You have like chemistry, biology, psychology, physics all developing, and people are no longer teaching a class called natural philosophy. They're teaching a class called physics.
Right, because it really should be a distinct. Philosophy is that territory about answering trolley questions, okay? It's about answering the hard value questions. Value. Is it... it's arguing about what you want as outcomes. Like, you could argue the philosophical dirty ground of you have $1 billion to spend on malaria. How do you, what do you do? Do you spend it all on a cure that might get you zero productive outcome? Or do you spend it on Band-Aids, which you know is automatically good because you're going to, help some people, okay, the nets and the therapies, giving them their pills and their mosquito nets. And yeah, in the short run, it works, but you're going to need $1 billion next week to do it again. And so how do you spend the money? That's a philosophical question because in a sense, there's no authority to go to. There's no group of facts in and of themselves that separate it and prove it, except you being a human being and judging value and saying, well, what do I place more value on, and why do I place it on that? It's almost like arguing attractiveness. Okay, it's sort of like a philosophical. It's such mushy ground. It's mushy. Philosophy is for the mushy stuff. Science is for the stuff where you can acquire evidence and you can draw really solid, you can make solid, accurate statements about the reality. It's hard to make a solid, accurate statement about value. It's easy to make a solid, accurate statement about the physical mechanics of the universe.
Mock Ostwald are planting their feet and saying, well, we can't let go of philosophy. We have never seen an atom. And I think this is really interesting because with the end of...
All right, so I don't know. Did they actually say those words? Did they actually say we can't let go of philosophy? Or are you just calling what they're doing philosophy because you don't like it? All right. Did they call themselves, did they say they're doing philosophy, not physics?
Natural philosophy. You do have physics, but you can get a physics degree and be a physicist and do atomic physics or statistical mechanics. But you can also get a physics degree and be a physicist and study the philosophy of physics and research the philosophy of physics and publish on the philosophy of physics. You
can have mush degrees. Yeah, you can do that whole astronomy thing. They call those physicists. But they're little black holes and their singularities and their hologramic bullshit and their information. Yeah.
Can get your
conservation of information. There's no conservation of information.
PhD in physics and then study and research physics education. You can get your PhD in physics.
Oh, whatever. Bullshit. Okay, who cares? The argument is how do you do any of this stuff without the obligation for there to be a battleground, okay, a testing ground, a rigid, rigorous, you're really saying we want the right theory, and the right theory should be able to compete against the other theories and win. It should be able to pass more tests. It should be able to provide more evidence. It should be able to do these things. And the only way you can have that happen is somewhere you have to be in a debate. You have to be obligated to answer a question. Do you really think there's a piece of real evidence somewhere that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet? Do you have any physical evidence that that's a fucking fact, that axiom of your physics? Do you think it's really smart to dent clay with round objects and say that's how you measure energy? You want a linear definition of energy? Use a nonlinear surface.
And work in civics, like how do we communicate physics to the public? How do we communicate physics to policymakers? All of that stuff is very...
How do we tell fables? And so again, we know the physics to policymakers is all about dual use. So it's all about, well, yeah, accelerators might be able to make the big gun, and we want a big gun, so yeah, we'll invest in that. And oh yeah, we'll invest in LIGO because it's the big ear, you know, and you might be able to listen to somebody doing something hanky-panky. So, you know, we'll invest in that because we might be able to use it to blow somebody up. I mean, it's just such bullshit. Science. Fuck. The scientists had control. CERN had control of the internet, and they all said, what's in it for me? How can I make some bucks out of this? And they sold it out.
Very important, and all of that is helmed under the umbrella of, you know, physicists. And what Boltzmann is saying with that quote is like, okay, let's do philosophy, but you cannot do physics without math. You cannot...
So this is the sort of bullshit part. Yeah, you can. Okay, trial and error works really well. A lot of scientists have used it. A lot of the best, I mean, people who made the guy who made the gun, the army used for decades or whatever. Lots of because they just kept working on a way to use the energy of the cartridge, the recoil of the gun, and use that to reload the gun and all that kind of stuff. And they worked it out by trial and error. The Wright brothers, all this stuff can be engineered. Now, I'm not saying math isn't useful. Formalizing relationships is great. You come up with a formula and you can find a specific thing you want to know. Well, that's great. But physics, the concept of what the physical universe is doing right now. What the fuck is the physical universe doing right now? Your illustration is woo all over the place. Glue on, poo on, zoo on, zip, all that kind of bullshit. And I'm saying that now the physical reality is that there's electrons and protons. They have these function called charge. The charge is obviously being caused by the fact that they react to the same field in an opposite manner through a physical mechanism that must be in the field. And that's all there is. There's just the motion of electrons and protons based on the charge they sense. And if they sense it in a certain way and they're arranged in a certain way in terms of their plus, minus, then they become magnetic and they send another signal to the universe in the sense that any light that hits them is reflected based on whether it hits an electron or it hits a proton. Whatever the force hits, it reflects differently if it hits one or the other. I mean, that simple explanation works, and you've turned physics into this mushy, philosophical, full of all kinds of spooky forces, spooky actions, spooky mechanisms, spooky particles, spooky all the way down. Mush.
Just do philosophy, because then there's no physics. And of course there's a lot of even modern physics philosophy papers and researchers who are physicists who do philosophy, and a lot of it's really good. But a lot of it's...
Oh, okay, yeah, a lot of it's garbage. And so what's the point? The point is that you must have a system to separate garbage from, fact from fiction and all that kind of stories, just stories, from things that can be demonstrated by some reasoning, logic, evidence, facts. You need those things. You need something where you can apply logic to, all right? And you need facts. And so what were the facts that developed the theory that somehow solar masses convert, their mass into bent space? What facts created that theory? oh, the fact is they're spending billions of dollars on a fucking wave detector, and the only way they can make it work is they have to make this energy insanely intense, even though it's not intense energy. So somehow they have to convert because they can't make this thing bright enough unless they come up with some magical way to take the raw mass, the electrons and protons, and convert them into gravity, in the sense of convert them into bent space.
Really, really bad. There's a version of epistemology where they think that they can talk about the philosophy of physics without knowing any physics, and it's all real word salad. You'll have papers and papers and papers where they're talking back and forth on how you define energy and how you define work, and it's all gobbledygook nonsense because none of it.
Right. So you're conceding that one of the most important subjects, energy and work, work is a silly word because it's all work. The stuff we don't call work, okay, the heat, all the other stuff, the stuff we call waste is still work from the universe's point of view. It was just as hard for it to do that thing as it was to do the thing we liked.
Is backed in physics. Like they're just rearranging the definitions of words and it's not physics. I don't know if the word salad thing made sense, so I would like to read you from one of Ostwald's papers because
Yeah, one paragraph, so who knows? Again, I'm not defending, I never read Oswald's theory. I'm just assuming there's probably more to it than just some mushy statement like energy fun. I mean, I'm sure there's more to it than that.
years later, this one's from 1907, Ostwald was working on this energetics theory. Here's an example of a word salad. Naturally, the question arises as to which role the magnitudes of capacity play in our world conception of energetics. The answer is that in essential points, the function of these is the same as the formally ascribed to matter by the earlier yet undeveloped condition of science. Oh.
So go ahead, read some Newton, and it's going to get a little bit tedious sometimes. Read anybody, and there's parts of what they're saying that, frankly, the language and the words, the vocabulary just doesn't match anything, so you can't really decipher it into anything. But clearly what he's arguing about is probably in the previous sentence. He said something about the idea of pressure and heat and all of those things, and is just making a wrap it up kind of statement that this is all a continuum.
If we consider the mass, weight, and volume are kinds of energy corresponding to magnitudes of capacity, we will again reorganize these factors in the old primary properties of matter. The secondary properties prove likewise to be magnitudes of capacity, which, however, do not possess among themselves such close spatial relations as above mentioned. It's a nonsense. Like, it's all words, but it means nothing.
So again, Bohr's response to Einstein is words that meant nothing, and he was declared the winner. I mean, there's the, it's like a half-true statement, but they republished his, Bohr's argument, all right? And it's 5 pages, and they had the pages in the wrong order, and nobody figured that out for 20 years or 30 years. That's how unreadable it was, that they couldn't tell that the pages were in the wrong order.
He's saying that we can't talk about mass and volume and density because atoms don't exist and we can't measure those things. The only thing we can experience is energy. So he wants to reframe.
Yes, and I would argue this is a key difference. There's energy that's free, moving the speed of light. And then there's energy pushing matter that's moving some much slower speed because it's pushing a piece of matter. So it seems a really neat conceptual vision to just recognize those are the only 2 forms of motion. The force free or the force pushing matter.
Something like mass or something like volume into purely energy. And of course, you can see how you could do that. Like Einstein talks about mass.
Right. So you're conceding the argument that this is a mushy subject in physics, that you really don't have this energy thing down anywhere, right? This whole thermodynamic argument is just kind of mushy in the sense that we know the universe is doing the opposite of entropy, in the sense that it is actively consolidating matter. You can't deny it. Okay, it's the Earth and the solar system is actively condensing, and then we know that supernovas happen and it's actively expanding. Okay, so it's perfectly reasonable to argue that this is an oscillating process, not a fucking it all ends in a cold death. Now, the only key to that argument is what happens to all the photons being radiated, if they don't hit anything. But is it possible for them not to hit anything, I guess would be the question. Is there really some place in space where I could shoot a little laser beam and I don't hit anything, ever? I guess the argument's pretty much no, there isn't.
Energy relationships, that's fine. But the question is why? A lot of physics of philosophy is like redefining words, and you're totally allowed to do that. But the thing about doing physics is not that it's a definition. Like the definition of work, for example, doesn't matter. It's just how we've defined it, and we use it to create a theory of dynamics.
Okay, we use it to create a theory of dynamics that doesn't say anything. That's just full of woo. You must conserve momentum, except when you don't have to. Except when you're making free momentum. Then you don't have to conserve momentum. You must conserve energy. Well, not kinetic energy. You can throw that away all the time. The ballistic pendulum, you can destroy 99.94% of the kinetic energy. Can just disappear. I mean, you certainly haven't measured it anywhere. You certainly haven't proven that the bullet has 2,000 joules of energy and the gun only has 2 joules of work energy. The gun can only do 2 joules of work and the bullet can do 2,000. You certainly haven't proven that.
And you could call work something else. Or you could take a third derivative instead of a second derivative and work out something with that and you would still get the same answer. But then it's the same physics. This is my problem with this. My response to Oswald would be like, okay.
All right, well, if I took what you just said out of the transcript, somebody could read it and say, what was that mush? Yeah, what was talking out of both sides of her face there, huh?
You're saying everything's energy. You have a mass energy and a volume energy and a density energy. You're allowed to do that. Fine. What does that buy you?
I'm just saying that none of it is... There's no mass energy. Mass isn't energy. But a piece of matter in the universe is going to be energized because it's going to get hit by a ton of force. You can understand just the gravity alone. Okay, whatever's causing it, it's a frickin' force. It causes things to move. So you've got to understand that every piece of matter is going to displace a field of energy, and that's its energy, is just the fact that it's in the space. It's taking up space in the volume of air, all right, and therefore the air pressure increases because the matter is displaced where the force would have been if the matter wasn't in the way.
Where do you get with that? What answers to observations can you explain that cannot be explained with the other theory, the one we're working with now? How is yours superior?
That's right, and that's all the testing you don't do any of. Okay, so nothing has been proven regarding kinetic energy. There's just no frickin' go-to experiment. But I can show you a car crashed at 50 miles an hour and a car crashed at 100 miles an hour, and I can show you that the car isn't 4 times as crushed at 100 miles an hour. So, I mean, there are pieces, there's shreds of little bits and pieces here that don't add up. The fact that the ballistic pendulum loses 99.94% of the energy and you haven't ever tested to see, well, it's heat or noise or some kind of bullshit that you make up. Oh, it went someplace. Well, show me where it went, okay? And the obvious fact is you haven't done any of these experiments, none of them.
Superior. What does it do? And Oswald has an answer for that.
Because you just do math. You do your math and your circular math, okay? You write a work equation that's wrong, okay? Work doesn't equal force times distance, it equals force times time. And then you have a gravitational theory of mgh when it's mgt. How long you're exposed to the gravitational force, just how long you're exposed to a paint sprayer, will decide how much gravity you have to fight or how much gravity is going to push you.
It cannot be my task to demonstrate that physics as a whole, including chemistry and physiology, can be represented comprehensively and exhaustively as energetics. This will even be granted by my opponents. They call into question only the usefulness of such a presentation, but I think that I have demonstrated this clearly enough here and in my numerous textbooks.
So whatever. Again, I'm not going to defend some guy who's writing textbooks.
Spray works best
whatever.
when your family actually wears it.
Fuck you.
I'm sorry, sir, you have not. And also, if you...
So he's dead. So again, arguing with the dead because you're afraid of a living debate. I won't debate you unless you're dead. Then I'll insult the fuck out of you because your dead people are really weak and they don't fight and they can't, they can't get angry at me. Pathetic.
You are suggesting that your theory is superior, that your way of thinking about physics is optimal. It is your responsibility.
Well, yeah, that's right. And he's defending his argument, and you have defended your argument with what? Just insults. Okay. Where did you prove some absolute statement absolutely incorrect? Beyond the vague notion that maybe he was talking about an atom in the form of a muffin. The jello, whatever the mold of the atom you were describing. But he's not against the concept of the fact that there's elements. So again, we didn't hear how he explained the existence of elements without acknowledging the fact that they must be coming in pieces.
Word salad. There's no math in this paper.
So again, math. So why pretend that physics is math? That the fact that the universe has bits in it and the bits are interacting, why is that subject have to include a single shred of mathematics? You can follow the bouncing ball. I don't need mathematics to do that. Now, if I want to build a bridge, I might need some mathematics to get it right the first time. But I don't need mathematics to understand how to build a building, for example. That, you need steel to be rigid, and you need cement, give it density, blah, 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 blah. You can figure that part out.
It is like 50 pages long. You can't have a physics theory without doing math. You're just doing definitions. That's what that is.
Definitions are fantastic. That's the whole point, is definitions. Putting words together that have been proven to exist. Okay, water is the wettest substance on earth because we invented the word wet to describe water. So yeah, of course it's wetter than everything else. I have to read this shit?
But this was not the real debate. It highlights a component of the debate of, I don't believe in atoms. The real debate is that, okay, you are leaving philosophy. You're leaving natural philosophy and you're going to physics. And now you're saying that all of your questions are answered. All of the things you observe can be explained by teeny tiny atoms that no one has ever seen and no one can ever experience, and you can't grab one and look at it. And
so again, this is her paraphrase of his argument. So again, I don't know if that's exactly all he had to say was, I just don't like that you have reduced the universe to parts because there's no God in it. I mean, what was his argument?
People like Mock are like, that's just absolutely ridiculous. And I think that's a valid criticism. At the time, you're thinking 1880s, early 1890s, no one had ever seen an atom. And yeah, Boltzmann is making the math look really nice. And
so what math? Show me the math he's making look really nice. besides it just being a theory about what happens when I throw I can make it in a pinball machine or something. I throw the pinball in, and it bounces off certain sides, and it's all got to be conserved, and I got to use up the energy unless I make it perfectly elastic. So it's just theoretical then. So you're making a pinball machine and saying, well, theoretically, what if? Okay, come on. I mean, it's dynamic. Okay, it doesn't have to be mathematical. It could just be understood as force in, force out.
He's getting correct answers. But are you just going to invent invisible particles to explain what you're doing? So this debate between the Machians and, Boltzmann kind of fighting for his life while all the other atomists are in America and in other countries in Europe. You have Boltzmann writing these papers, going to give talks, and you have Mach writing these papers, going to give talks, and they have these spats in the literature, they have these fights at conferences, and this is often painted as a very adversarial relationship, they absolutely hated each other. So one of the books I read for this video right now is called Boltzmann's Atom. This book kind of paints the picture that Mach is a little bit responsible for Boltzmann's, eventual death by hanging himself. And
oh gee, so great. Whatever. It's just so the whole point is this has to happen. Argument is essential. Testing is essential. So yeah, I mean, if somebody shows up to come to the physics, test your physics theory, and they come up and they put the Bible down on the table, I mean, yeah, it's time to just say, okay, let's just move to the other room, let this guy with his Bible do his thing, But, the whole idea that obviously we wouldn't know of this being historically significant if it wasn't taken seriously. Just as, I mean, I could argue that Einstein's lament about how physics went the wrong way is not an unreasonable lament. 2 years before he died, he said, look, I've been studying photons for 50 years and I haven't improved my understanding one iota. So, I mean, it's a clear concession that they hadn't advanced the subject at all, in terms of leaving it in a quagmire of dual theories, of dual mechanisms that are in direct contradiction with each other. They're not compatible theories. Many worlds is not compatible with Copenhagen and this and that. I mean, they're all incompatible mush.
I don't get that picture from reading the actual text, because this is this huge debate. It's the scientific debate. You have Boltzmann doing experiments. You have Mach doing experiments. You have all these people getting these results, and they kind of come to the same conclusion. Boltzmann and Mach are if atomic theory works, it should be used.
Okay, whatever that even means. So we could end with that one. The usefulness of the wrong answer. So and you can just imagine how much has been missed, okay, because they don't have a right theory. So just imagine how much better they could have done if they actually had the correct theory of how the damn shit works. And when you really analyze most of the stuff that does create advancement, it's not perfectly consistent with those theories. I mean, landing on the moon without Einstein's formula is kind of an example. You don't need Einstein to land on the moon, okay? So there's all kinds of places where it's sort of demonstrated that the theory, although you might find some general utility in that it keeps you in the ballpark, you're just in the ballpark. You're really not on the pitcher's mound. You're not at your position. You're not in, it's not a rational game. You just have 18 players on the field, but you don't have any of them in the right places.
But you should use it as a tool. And you should say, we can think of this as little atoms, but we don't know if atoms exist yet. And that's it.
Well, I mean, the part that you're still missing is that if you think about it as little atoms, you're still missing it, because they're really electrons and protons. And the fact is, electrons and protons are charged, and therefore they can have imbalances. And you could look at it from one side and it looks more negative, and you look at it from the other side, it looks more positive. So the fact is there's a whole bunch of the dynamics of how those atoms behave that is completely dependent on the function of the electrons and the protons, not the function of anything called an atom. And the atom really is defined by its nucleus, not its electrons anyway, right? Because you have all these isotopes that are basically very similar compounds in some respects, or different, frankly. They can have different physical properties based on being an isotope. So we know that the real rigid part of the atom, the signature of the atom, is its nucleus. That's the core of what this thing will probably do. Okay, what it probably will do in an environment, because that nucleus is rigid. It's unchangeable. All right, difficult to change, let's just say. All right, so it's probably enough of a video, but just more crap. It's so arrogant. These people who think they have some glimmer of the truth because they've written a mathematical formula. And again, 1/2 mv squared. What the fuck sense does it make? 1/2 amps times volts squared. That's going to give you watts? I don't think it will. I mean, it's just such a wacky idea, a velocity squared. It's not a geometrical reality. It's not a geometrical thing. A squared velocity. Doesn't make any sense logically. A cube of velocity? No, I'm afraid not. So anyway. So till the next time and such and so forth and whatnot. I could read, right? She's talking about rubbish and jargon and crapola. Let me just read some of this. Let's see. It is my firm position that it is unethical to imagine that people's lives, rights, and experiences can be debated or disagreed upon. So their interpretation of an experience can't be disagreed upon. If they believe in God, then God exists? I don't think so. I'm not interested in arguing about such things. I'm interested in curiosity, kindness, and introspective engagement. What the fuck is that? What the fuck is you don't publicly talk about introspective engagement, right? That's something. Well, I guess you could talk about your introspective engagement, but it wouldn't be engagement, right? It'd be just my diary, okay? With the subject of impacts of ordering in an unjust world. So what the fuck could that mean? Right? So this mush, she sees she has an affinity for this mush, but she didn't have much affinity for the other guy's mush. I'm interested in curiosity, kindness, and introspective engagement. What the hell is that? With the subject. So she's introspective with a subject. So I don't know. It doesn't even make sense, right? You're interacting with a subject. You're not introspecting. And impacts of ordering in an unjust world. Welcome to the paradox of open societies. For a space to be truly progressive and inclusive, it has to be explicitly intolerant of intolerance. So again, that's like saying, okay, so if somebody's rapey, I won't get in his way. So there's no crime you would prevent through proper punishment. I consider it my responsibility as a person paid to explore and expose the workings of intolerance via my writings at the correspondent to abide by the paradox. So this is almost like the guy talking about his textbooks. So she sees value in this mush. Okay, this mushy evasion of any responsibility to talk something rational instead of talking some kind of shit. So whatever. I have every hope that, I mean, look at just for the tackiness of it. I'm all against this shit culture, okay, where women are just, this is all they're for, okay, it's eye candy for men. Now, it's a fact, okay, that women are eye candy for men. It's just an absolute fact. That men have a compulsion to pay attention to such things, but clearly I'm arguing that a woman should be quite free to be respected as a human being first, okay, and as eye candy. Who cares? Yes or no? They can play golf or not play golf. Okay, they can go play tennis or not play tennis. They don't have to be these other things. They just have to be a human, okay, that has a brain, and they're going to talk about what they think. And they can do that, I would argue, just as well as a man can, okay? But the truth is that so many are doing it in this cliche Barbie format of playing both. Pretending, okay, using one to blend into the other. Let's just say that, and then hiding as a woman. I'm a girl, so therefore you have to open my door, or you have to do this, or you have to do, and that kind of bullshit. That somehow, I can call a man a stupid fuck, but somehow I can't say it to a woman, when I should be able to. Okay. All right. You ignorant slut. That is, yeah. I mean, these aren't forbidden insults. Calling a man a dick or calling a woman a cunt. Yeah. Come on. No difference. Grow up. Smell reality and such. And again, I apologize that men are rapey and men are exploitive and men cheat women. Okay, and they lie. They do lots of things that I'm never going to defend. Any kind of physical trespasses and thefts of any kind. Of fair interaction. But there's way too many women who want it both ways. They want me to, throw my coat on the mud puddle. They're expecting that I treat them different and better, and I'm not obligated to do that.